Biostatistics is an integral part of the research methodology. So, the first question comes whenever we think of biostatistics, is it comprehensible? Because for most of the medical students, when we are analyzing with the clinical data, we are dealing with the patient, we are dealing with the clinical mechanism and prescription, it often comes to our mind that this kind of vast array of a tough subject called statistics, and the part of which is known as biostatistics, which is applicable to the health research or the fundamental bioresearch. So this comes often in our mind that as a physician, as a healthcare professional, as a nursing staff, whether we can grasp the nitty-gritty of this subject or not. So for this, I would like to tell you that in the next few slides, you will actually sown a seed of basic concepts of the biostatistics so that it will be easier for you to understand the next advanced steps that we'll be talking later. Now, let's start with the definition of the statistics and biostatistics. Statistics is the science basically which deals with the collection, classification, and tabulation of numerical facts as the basis for explanation, description, and comparison of the phenomenon. What does it actually mean? It means biostatistics actually analyze the data. Data means any information that is getting generated or is already existent surrounding us. In this matter, whenever we are dealing with the collection of such data, classifying such data according to their types, and tabulating those data, after that we are analyzing those data to come to a meaningful conclusion is basically the biostatistics. And what does this meaningful calculation does? It does explanation, description, and comparison of the phenomenon that is happening around us. The biostatistics, also known as biometry, it is not the biometry you put through your finger. It is a synonym of the biostatistics, which says that is a branch of the statistics that applies these statistical methods of collecting, analyzing, and classifying the data, these statistical methods to a wide range of topics in the biology. It encompasses the design of biological experiments, their collections and analysis of data from those experiments, and interpretation of such things. It means that biostatistics is a specialized branch of the statistics which exclusively applied to the bioscience. On the other word, nowadays that health research is expanding in an exponential way, as I told you earlier in my previous videos. Uh, because of this, the health researchers tend to believe that there is something separate subject called health research statistics, HRS. So this health research statistics is nothing but another subset of the biostatistics which applies exclusively to the health research methods. Now, let me tell you a bit. I won't want to bore you saying all the histories of the biostatistics. I'm not a historian, but the thing is, you need to know a bit about the history. I'll just tell you in a very nutshell that what was happening and how this biostatistics was started. Biostatistical modeling is basically an integral to the modern biological theories. Earlier, what happened is everybody used to propose their own theory which doesn't have any basis or existence, and everybody whatever they used to think they just proposed as their theory or law. But the thing is, whenever this modern biology came into the existence, all the scientists tend to believe that there should something with the standard methodology and biostats. So biological modeling, this is basically depends on the biostatistical modeling, is basically an integral part to the modern biological theories. Particularly in earlier era, it was exclusively applied to the genetic studies. Gregor Mendel, you have heard about his name, Mendel's theory. Gregor Mendel pioneered to use these statistics in understanding the genetic segregation of patterns in peas. That peas, in peas, there are something called genetic segregation that was done by Gregor Mendel through the biostatistical methods. In early 19th, I mean, in early 20th century, a debate arose between Francis Galton, proposed the law of ancestral heredity, and William Bateson, supporting the Mendel's view of exclusive parental inheritance. This debate was settled by 1930s through statistical reasoning. So it doesn't matter who are giving which theory, but when this theory will be settled down by the statistical reasoning and the biostatistical methods, then it is quite well established, and people around the scientific community tend to believe that. When this settlement was done regarding this genetic theory conflict, that actually led to the development of neo-Darwinian synthesis. So Darwin's theory comes into existence. In the same way, population genetics and integration of genetics and evolution were further developed through the efforts of key figures. Moreover, you will just be fascinated after knowing that the initiation of the statistics occurred through the initiation of the biostatistics. So statistics didn't came first. Biostatistics came first. So the statistics started with the initiation of the biostatistics. Not like that, the statistics was came first and then subset of the biostatistics formed. No, it was actually vice versa. Because in the early 90s, as I have told you regarding Gregor Mendel and neo-Darwinian synthesis theories, after that, one drastic evolution occurred through the Ronald A. Fisher. He is one of the biggest, considered to be a father of the biostatistics. However, what was the actual contribution of the R.A. Fisher? You have heard about p-values, right? That p-values, which is often used in the clinical trials and other studies, that we say that p-value less than 0.05 or less than 0.01 means statistically significant, and this study is actually that medicine particularly works. So all these theories completely based on the p-values or the statistical significance. This p-value concept was first given by R.A. Fisher. Apart from this, there is a very important test in our statistical methods called ANOVA, analysis of variance. This ANOVA was also the contribution of the R.A. Fisher. After that, Sewell G. Wright, another stalwart of the biostatistics, he introduced the F statistics in the ANOVA and inbreeding coefficient methods. I will tell you later when advanced statistical classes will be on, and how this is how later on Dr. JBS Halden, you have also heard about his name, the Halden soup. Dr. JBS Halden wrote his book called The Causes of Evolution. This book actually reaffirms the natural selection as primary mechanism for our existence, right? This actually aligning with the Mendel genetics and introducing the theory of primordial soup. All these things occurred with the biostatistical segregations. So hope you understand that how much biostatistics was important for establishing any scientific facts or theories. So these are the uh, stalwarts, among the stalwarts of the biostatistics, Dr. R. A. Fisher, Carl Pearson's. You will come to know that Pearson statistics, Pearson coefficient. Then Dr. Gauss, he's a actual proponent of this Gaussian curve or the normal curve that we'll be reading later. The central limit theorem comes out of this. And this is Douglas Altman. He is having a lot of contribution in the clinical trial statistics and also for the systematic reviews and meta-analysis theories. So we'll be learning about all these concepts in the later parts. So what are the let me tell you about the sources of uncertainties in the medical sciences. Hope I think that you were thinking that from where this comes, right? We are talking about biostatistics. But the thing is, before seeding something in your mind regarding biostatistics, you have to know what are the medical uncertainties that is beyond mostly our control. After reading these uncertainties, you will come to know actual importance of the biostatistics. So the medical uncertainties actually occurs in four ways. Number one is the natural variation. Number two is the intrinsic variation. Number three is the observer errors. Who is actually observing, suppose physician is often misdiagnosing something, right? So this is purely the observer's error and incomplete knowledge. Everybody knows that medical science or any branch of the science is a vast sea where the knowledge cannot be completed by any means because it is infinite. So, because of that incomplete knowledge, it is an unavoidable uncertainty in the medical science that nobody knows every kind of disease, every kind of therapy, and every kind of patient care. They're evoluting themselves with time. Let me first tell you about the natural variation, how this occurs. The first uncertainty in the medical science. It means in assessment of medical parameters due to partial compliance by the patients and due to incomplete information in conditions such as, suppose, some patients in coma. So, for the first point, assessment of any medical parameter, suppose you are reading the blood pressure of a patient, right, with some manual BP machine, sphygmomanometer. You're just looking into the blood pressure of that particular individual, and you are saying that, okay, the blood pressure of this individual is 138 by 82. Okay. When another physician measures that, he found that it is 176 by 80. Another physician found that it is 174 by 78. So see, there is definite some medical parameters variation. It is not because of, yeah, definitely there is a factor of the observer's error, but it is not always because of observer errors. But you know that many of the patients are having their blood pressure correlated with their stress levels and physical activities. So it is a fluctuating type of parameter. So often, like serum cortisol level throughout the day, it is in the morning, it is lowest, in the evening, it is highest. Why? Because of the whole day stress. So there are multiple parameters in our body which are quite fluctuating and very uncertain in their reading. So the assessment of any medical parameters, and of course, there might be some machinery errors of course also. And the second one is due to partial compliance by the patients. Often the patient doesn't comply to the actual information that the physician asks the patient. Okay. And the third one is due to incomplete information in the condition such as coma. Suppose some patients are in coma and you are asking them to put their hand on. They can't. So this is also a type of natural variation. It is beyond our control. There is something called intrinsic variation. It is the second point of the medical science errors. The first one is biological age, biological variations due to age, gender, heredity, parity, height, weight. So we don't have any control on anybody's gender. We don't have any control on anybody's heredity, right? So also due to variation in anatomical, physiological, and biochemical parameters. So every people is different from each other. It is the precision medicine's theories. It is the homeopathic basic principles that every person is individual. Every person is different from others. That's why they are almost all the things, including heredity, parity, height, weight, anatomical variations, LDH levels, liver function test levels, PFT levels, all these things are different from each other. Why? Because each and every person is individual, and this is an intrinsic variation that every person possesses. Second one is environmental variations such as nutrition. Everybody is not getting same nutrition, right? Like smoking status, pollution in a particular area, facilities of water and sanitation. All these things are beyond our control, and there must have certain variation in each and every geographical locations and persons. Third one is sampling fluctuations because of entire world cannot be studied, and at least future cases can never be included. This is a very important intrinsic factor in the biostatistics. We often say that to test the efficacy of a drug, we cannot involve the entire population in our clinical trial, right? We cannot include the entire population in our study of question, because if we do that, then it will be very time consuming, very resource consuming, and it is not feasible as well. It will take years and years to conduct that study. So that's why it is not possible. So For this, we have a technique called sampling. We actually take or cherry picks certain part of the population, which is known as sample, based on certain assumptions and principles. Uh, so whenever we take some samples from different populations, so sampling fluctuation must be there, right? And the fourth one is the chance variation due to unknown or complex component factors. It is known as confounding factor. There must be some chance variation, some systematic errors that it is beyond our control. We never know. There might be thousands of variables in a clinical trial, but we are measuring only 14 or 15. So it is a chance variation. And the final one is the observer's, the third one is the observer's error. It is the carelessness of the providers such as physicians, surgeon or nursing staffs or radiographers or pharmacists. So often it happens that I gave you the latest example, best example, that misdiagnosis. Often it happens that you are giving me an ECG. I'm saying that this is absolutely normal, and you are giving it to some other experienced cardiologist. He is saying that okay, there is some lateral wall myocardial infarction. So this is called observer's error, and because of this error, many things changes in the patient's lives and as well as in the clinical trials. Third one is instruments error due to no use of non-standardized or faulty instruments. If you use faulty instrument, like I told you earlier, like sphygmomanometer, if it is faulty, uh, nowadays, for a good example, nowadays there is abundance of use of electronic sphygmomanometer, right? And you know, if you just move your hand like this during the measurement, and if you just change little bit of your position, then automatically the sphygmomanometer will give you the error reading. So this much problems or variations the sphygmomanometers has, especially the electronic sphygmomanometer. So erroneous measures is because of, not because of the observer, but because of the instrument, right? So instrument error is also counted as electronic observer's error. So this all human observer error and systematic observer error, the electronic observer error both comes to the observer error part. And not collecting the full information. If you are in a hurry, uh, you want to go to home, in a movie, in an office, so you are in a hurry, you are not giving proper time and evaluation to the patient, which results in the incomplete information in the clinical trials or in the patient care. Final one is the inconsistent response by the patients and other subjects under evaluation. There are multiple factors which actually leads to the incomplete information by the patients. Often it happens that based on the educational status, based on their socioeconomic culture, based on their geographical region, based on their language barriers, patient often is having variations in understanding your questions and responding to that question. So this variation depends on thousands of factors, as I told you, like socioeconomic status, uh, geographical locations, cultures, all of these things. So inconsistent response by the patient and other subjects under variation. This is also very important. And final one is the incomplete knowledge. You know, nobody is having complete knowledge pertains to diagnostic, therapeutic, and prognostic uncertainties. So it actually leads to the uncertainties because of the lack of knowledge, right? And the second one is predictive uncertainties, such as in survival duration of a patient of a cancer. So it is to some extent depends on knowledge. If you have good enough amount of knowledge, you can diagnose a patient easily and tell that patient will survive for next 6 months, 8 months, 9 months based on your predictions and the clinical judgment. But often this cannot be happening if you don't have less experience in that field, which takes around 10, 15, even 20 years to get such intuitive idea that how much the patient will gonna be survived, right? And the third one is other certainties such as how to measure positive health. So everybody of you have at least gone through the practice of preventive and social medicine or the community medicine subject. In the past textbook, it is completely written in a bold that positive health is more of idealistic concept than the realistic proposition, because it is not in our hand how to measure positive health. If someone is happy, then it is positive. If someone is spiritually dimensional, then it is positive. If someone is having good health status, good physique, then he is positive. If someone is earning maximum amount of money, then it might be positive. So the positivity in the health depends on the perspective of the person and the individual who is assessing them, right? So that's why it is very difficult to say which is positive health, which is negative health. So basically, biostatistics. Now, again, coming to the biostatistics, after going through this hell lot of uncertainties, ultimately, we should tell that biostatistics is the science that helps in managing medical uncertainties that we are talking about in past few minutes. So all these uncertainties, all these four uncertainties coming out of the medical science actually managed by the biostatistics. And there are multiple things: correlation, regression, adjustments, multiple functions in the biostatistics which can really make you or help you understand the data in a positive way, eliminating all these uncertainties beside. So biostatistics in medical science is having three basic advantages in developing a research design that can minimize the impact of uncertainties. There might be a question in your mind that if this much uncertainties are there, then how would we conduct the clinical trial? In this clinical trial, when we are evaluating the effect of certain medicine, you often think that if this much uncertainty is involved in the patients or in the physicians or in the machineries, then how these clinical trials is going to make a clear statement about the efficacy of the medicine? It's because we are gonna applying the biostatistics at the later part of the clinical trial to analyze the data in a meaningful way, and that will minimize the impact of the uncertainties that we're talking about. This is the most fascinating part of the biostatistics. Second one is in assessing reliability and validity of tools and instruments to collect information. So I'll tell you about reliability and validity in later part of this session. So reliability and validity, I will upload a different video on the reliability and validity. This is very important in all part of the clinical trials. So it helps in assessing the how much reliable a case is, how much valid a case is. So in the third part, in the third advantage is in proper analysis of the data. So thank you very much for your patience hearing. So this was the basic foundation of the biostatistical concepts. Just one takeaway message that we want to tell you to take from here is biostatistics is handling almost all kind of uncertainties involved in the medical science. Thank you very much.